Welcome to Introduction to Risk-Based Inspection, presented by AssetWise Ivara Performance Management, Part 4. Introduction to Risk-Based Inspection, Rbi Assessment in APM, Degradation Types, Age-related, Non-Age-related, and Strategy-based. Failure modes in APM are categorized in three degradation types or failure characteristic: age-related or trendable degradation type, non-age-related random degradation type, and a strategy-based degradation type. Wall thinning by internal corrosion can be an example of age-related degradation type. A stress corrosion cracking can be a non-age-related degradation type. The only strategy-based degradation type in APM is the corrosion under insulation. Strategy-based degradation types are age-related, but they are not easily trendable. If an asset is subject to a failure mode with age-related degradation type, the combination of criticality and confidence rating is used to derive the inspection interval factor. Then this inspection interval factor is multiplied by remnant life to determine the maximum inspection interval. As it was mentioned before, the interval factor in APM RBI methodology can change between 0 to 0.8. For example, for an asset with a negligible criticality and very high confidence, the interval factor can be a value of 0.8. This means that the next inspection for this asset can be scheduled at 0.8 times of its remnant life from the current inspection date. And this is calculated, the remnant life is calculated based on the corrosion rate selected for that asset. On the other hand, an asset with a very high criticality and low confidence rating can only be scheduled for the next inspection at 0.1 time of its remnant life. This means that an asset with a high criticality, which we have a kind of a low confidence in the stability of its degradation mechanism, or the monitoring of its condition, or the previous results of the inspections, can have to be inspected much sooner than the other asset which has a negligible criticality with a very high confidence. For those assets that they are extremely critical, regardless of how confident we are in their rating, analysis with specific risk management techniques has to be done to define when and how the next inspection should be carried out. Also, you can see here that an asset with a medium criticality with medium to high confidence rating is going to have the interval factor of 0.5. This is the same interval factor that is prescribed in API 510 or API 570 for an average asset. So an average asset, as you can see in this definition, is an asset with medium to low criticality and medium to high confidence rating. And the interval factor for this asset is going to be 0.5, meaning that the next inspection will be carried out at the half of the remnant life from the current inspection date. A non-age related or random degradation type is a degradation type that is more dependent on process conditions and generally is associated with exclusion outside the integrity operating window. It's very difficult to establish a time-dependent corrosion or degradation rate. Therefore, calculating the remnant life for the assets subjected to this type of corrosion, it's not possible only based on the selected degradation type. A non-age related degradation type also requires careful monitoring and control of all relevant process parameters. In other words, the integrity operating window has to be monitored to ensure that these type of degradations are controlled properly. The criticality rating and confidence rating are applied to indicate whether the system under consideration can be operated safely based on monitoring and opportunistic inspections, or whether more detailed analysis outside the scope of the APM RBI methodology is required. So as you can see in this table, if the asset has a high or extreme criticality with, regardless of any kind of confidence rating that we have for those assets, a detailed analysis is required to specify what process monitoring regimes should be applied to those assets. For the average assets with medium or low criticality and high to medium confidence rating, we can apply extensive monitoring strategy and an opportunity-based inspection regime to define the susceptibility of these assets to the degradations and failure. A strategy-based or corrosion under insulation degradation type is age-related but not easily trendable. Making a reasonable, accurate estimate of remnant life of an equipment is not possible since the time of wetness is difficult to predict at any specific location on that insulated equipment or piping. The prior condition of the protective coating or insulation and the presence of some chemicals such as chlorides also play an important role in assessing the probability of a failure and makes it difficult to assess. Therefore, for corrosion under insulation, number of inspections or maintenance strategies are developed with a predefined time schedule based on experience. These strategies prescribe the inspection maintenance activities for a long period, and the future action following these activities will depend on the results of the latest inspection and maintenance action. The appropriate inspection maintenance strategy is determined by the combination of criticality and confidence rating. And a distinction is made between carbon low alloy steel and stainless steel, meaning that two different strategies and corresponding inspection and maintenance strategies are applied on carbon steel and stainless steel materials. So, in summary, we have two failure mode degradation types. The degradation type that are age-related. The age-related one can be trendable, like wall cleaning. For this type of degradation type, we are going to estimate the remnant life based on the remaining corrosion allowance and a selected corrosion rate. For the non-trendable ones, which is going to be the corrosion under insulation or strategy based, we are going to define the probability of a failure based on the questionnaires, which are different based on the material type, stainless steel or carbon steel, and based on the probability of a failure, criticality assessment, and confidence rating, we are going to define what's the inspection scenario. For the degradation type that are not age-related, such as stress corrosion cracking or mechanical fatigue, we are going to either define the probability of a failure based on questionnaire, or there are some degradation models generally developed outside the APM scope, and sometimes the redesign is also required. Based on this, we can only do the process monitoring or opportunity-based inspection. To select a corrosion rate, we are either going to rely on the measurements if they are available, so based on the trends of the previous measurements of the thickness, or based on the experience, the historical corrosion rate available, or some degradation model which are going to give us some theoretical corrosion rate. Whatever is going to be the maximum value between this or the design or default corrosion rate is going to define our corrosion rate for that specific failure mode on that specific equipment. Here is a summary of RBI assessment. RBI assessment typically starts with collecting the asset integrity data, then defining the corrosion loop and the credible or applicable failure modes for those corrosion loops. After that, the criticality analysis is going to be carried out on those failure modes. Depending on the result of the criticality analysis, if the failure mode is not critical, so no inspection is required, for the high critical or extremely critical, we are supposed to do some detailed analysis and risk mitigation activities which can be out of the APM Rbi Assessment methodology scope. For the criticalities of low, medium, and medium high, now we will go and follow this part of the logical process. We are going to define if the failure mode is age-related or not age-related. For the age-related one, if it's not a corrosion under insulation, it means that we are going to have some thickness measurement reading, and depending on the confidence rating and criticality analysis, we are going to define an inspection interval factor, which is going to define when is going to be our next inspection, depending on the remnant life of that equipment from the last inspection. If we are dealing with the corrosion under insulation or a strategy base, again, depending on the criticality, we are going to define whatever is going to be our design inspection and process monitoring strategies. If we are dealing with the non-age related failure mode, again, we are going to define the process monitoring requirement based on the criticality and confidence rating. After the assessment is done, then we are going to execute the defined action and inspection tasks. And based on the result of those inspections, we are going to review our Rbi assessment and update the asset integrity data according to that. This is the summary of a Rbi assessment process. In summary, this 4-part training module has introduced you to risk-based inspection RBI concept, benefits and limitations, RBI assessment process, RBI assessment in APM, criticality and confidence assessment, corrosion loop definition, degradation types, age-related, non-age-related, and a strategy base.